Hi everyone, my name is Evgeny Stemasov, and I'm here to present, on behalf of my co-authors, our work on DungeonMaker, which is a fabrication-augmented hybrid board game that embeds craft and damage in a game experience. Let's start with a quick look at some of the aspects involved. Players can craft equipment for their figures and personalize them using a 3D printing pen. The game is situated inside a laser cutter, and it can sense player inputs and, for example, move or damage player or non-player figures alike. Let's start with a bit of background that informs the development of DungeonMaker so that it becomes clearer as to why we built it. We're all familiar with video games, which have all been an incredibly popular pastime activity. What is an increasingly common element in them is some degree of personalization. For example, choosing a skin for your character or designing something that's visible to other players. These are aspects of self-expression and individuality. Another element that is rarer are permanent consequences. The notion of permadeath is present in games like DayZ or in specific game modes of other games like in Torchlight 2. Your character dies, you lose it forever, which introduces a more intense risk and alters player behavior. Now there's also the space of board games, or more recently, hybrid board games. We also have these potentially permanent consequences, for example, character deaths in Dungeons & Dragons. You invested in this character over several sessions and risk losing it in combat. This continuity and growing attached to elements of a game can also manifest in people creating and retaining mementos of gameplay. For physical games, this is likely easier to do. Here we have an example of the Pandemic Legacy game and a player's monument to a specific campaign. When we talk about hybrid board games, we see that there are both tangible and intangible elements to them. A physical board and figures, and often a digital app to guide gameplay or provide calculations, for example. There is also this tension between physical and digital elements and their effects on one another. Most happen within the logic of the game, and the player has to enact them in one way or another, for instance by moving non-player characters following the guidance of the app. And this is linked to the notion of distributing roles and responsibilities across players. Who's responsible for what and how is it being woven into the narrative, for example. And hybrid board games do automate some of the roles in this constellation, for instance, scorekeeping. So based on these aspects, we see three challenges that are interesting to us. First of all, how do we address this disconnect between physical and digital in a hybrid board game? How do we enable some sort of synchronization that is not manual? The second one would be, how do we introduce physical personalization in these types of games? How may this change attachment or maybe gameplay itself? And lastly, there is little to no physical risk in hybrid board games, and continuity of personalized elements across sessions is also often limited to character sheets or the player's imagination. I'd like to briefly go over our design rationale and process here. We initially conducted a survey to inform some of our design choices and probe sentiments of damage and reassigned roles. We had different stances towards relinquishing tasks to technical systems, and players saw the prospect of damage differently depending whether figures are self-made or purchased, for example. We asked ourselves what fabrication devices like 3D printers, laser cutters, or CNC mills can provide on a technical level, and how this may map to game mechanics. We have creation, destruction, movements, outputs, and inputs, which are all present in hybrid and analog board games to some degree. And these approaches have been discussed in academic research, similarly to the challenges of hybrid board games. When we look at fabrication games, we see, for example, concepts that leverage machinery for embroidery, which leaves a particularly valuable and intricate memento. The concept of value creation was already considered through the lens of destruction and objects you may own. And lastly, there were approaches to fabricate content from digital games. Now, this is not a fabrication game as such, but Fabo still highlights how fabrication is a bridge between digital and physical aspects of games. The concept of hybrid board games has also received quite a bit of attention. Sparrow and Rogerson, for instance, looked at how people dealt with doing remote board game sessions during the pandemic. There's also the hybrid digital board games model, which outlines the individual functions or aspects that hybrid board games may entail. And there are also prototype systems that explore building hybrid board games. In a more technical realm, there are various works that try to augment fabrication devices with new functionality, adding projected outputs to guide users, or use a printer head to actuate and assemble objects are examples of that. And there are also approaches that add different effectors to devices to enable processes like patching, for example. So based on the literature and our formative explorations, we settled on these 3 design goals. We want to enable personalization in or through physical media. We want to include physical risks and continuity alike. And lastly, we want to enable some kind of bidirectionality between these physical and digital spaces that are present in hybrid board games. And when we look back to the status quo, these elements to some degree are present, but are often rare and underdeveloped. To give you a glimpse into the design process, it mostly happened through an online whiteboard tool. We used Miro for that. We started with an analysis of existing fabrication mechanics and sample board games. The story and the game flow was developed here too. Playtesting was also done in this online whiteboard using dice simulators initially, and after the hardware setup was functional, playtesting was also done with that. There were multiple rounds of balancing individual mechanics, and their specific hardware setup was also planned here too. Now here there was some cross-pollination between game concept and hardware capabilities. For example, the map grid depends on the figure size, and the figure size depends on the gripping system capabilities. Alright, so let's talk about the implementation and the technical setup of DungeonMaker. This is a brief list of components that we used. More detail is in the paper if you're interested. DungeonMaker consists of a modified laser cutter, a gripping system, a camera-based input system, and this is all tied together with a game application. I'll be using this graphic as an overview to walk us through the individual components that make up DungeonMaker. Let's start with the outputs. We use a short throw projector mounted above the laser cutter to display the game board and the UI. UI is rendered on the lid, and the board is projected into the laser cutter into the work area. We also have a speaker that takes care of audio narration. What we can look at next are the motion components of DungeonMaker. We've designed an attachment to the laser head that contains a camera and LED lights to illuminate the workspace below. This is used to detect Enrico markers on each figure. The position of the figures is then used to control movement. After detecting the figure, correcting the position, the head is lowered, an electromagnet turns on, grips the figure, and repositions it. This is how DungeonMaker moves figures according to player commands. Let's move on to the figures that I've just talked about. So, as mentioned before, they have some additions. First of all, we have a back scaffold. On top of it, we have a metal nut so that it can be gripped with an electromagnet. We also have this base, which provides a standardized area for the figures, making it easier to move and damage them. We also have this Enrico marker on the base, which allows us to track them. And these components are modular and can be replaced. This makes it easier to deviate from this base design that we have and model both player, characters, and more sophisticated NPCs, for example. DungeonMaker is also able to process a range of inputs and commands from the players. We have behavior or movement tokens that players can insert to choose actions or give motion commands. The input module also processes dice thrown in this bowl. So the tokens have a human-readable side on top and a machine-readable side on the back of them. So how this works is that we have this acrylic plate on which the inputs are positioned, and below, with some space, a camera connected to a Raspberry Pi. LEDs illuminate the surface, and the input, dice values or markers on the tokens can be parsed and passed on to the game logic. There is another aspect where this camera-based input is used, namely for the assessment of player-crafted objects. So they have access to a 3D printing pen at the beginning of the game and during it too, to create artifacts. The first type and most commonly used is equipment. In the case of DungeonMaker, these are little weapons that you build. This ties to artifact assessment aspects, right? The system extracts contours from what the players build, assigns them to a weapon type, and rates quality. This connects crafted objects to actual gameplay relevant values. This input can also be used for other objects that players craft. In the game we implemented, they see hints as to how a key they need looks like, and they have to quite literally fabricate the solution, which is evaluated for correctness later on. A core aspect of DungeonMaker is the prospect of physical blasting damaged figures and equipment. Based on the marker and a standardized figure construction, we can selectively apply damage to regions of the figure. In the game, this happens at specific thresholds of health and reduces the power of the character accordingly. We implemented a scenario for this hardware platform that tries to leverage all these elements for a game experience. I've mentioned some of the aspects already. Now, the players have this common goal of escaping a dungeon, which is a classic setup for such a scenario. They are still free to explore the board, which some may take seriously, some may not, but the underlying goal is rather straightforward. To escape, they have to gather clues on how a key looks like and reach the door with a fabricated copy. Across the map, there are several non-player characters that trigger different interactions. We have a jailer that you can extract hints from if you win a little minigame. We have a merchant that lets you create new equipment for your character. And there are enemies that trigger dice-based combat. There are also chests scattered across the map, with some containing bonuses, others negative effects. We then set out to evaluate DungeonMaker in a small exploratory user study. We had 12 participants, all with board game. So we had 12 participants, all with board game experience, and they were recruited as groups of 3, and we expected them to be familiar with one another. We did see an increase in arousal in the self-assessment mannequin questionnaire between pre- and post-game. We also saw an increased connection with your own figure, which we measured with the inclusion of other in the self questionnaire. But we were interested in how people played and how the setup affected them mainly. All participants had very positive feedback on the experience. There were also interesting observations, like the quality of equipment changed player strategies, whether to provoke or avoid combat. Users also tried to engage in kind of world building, trying to explain why their weapons were particularly good or not. And we also saw curiosity and joy regarding individual functions such as assessment or movement of the system. Based on the design process of DungeonMaker and based on the study, we outlined 6 design considerations that we deemed to be relevant and kind of helpful for comparable setups and designs. First of all, we see this notion of physical expression that has a meaningful effects on gameplay to be an aspect of agency. It can be a powerful effect and create value, attachment, and enjoyment. It can also facilitate aspects of physicality and continuity. When we introduce physical risks, we also have to consider why a user may want even to take them and find the right balance. For instance, we had this very physical risk of enemies present, damage lurking, but the rewards and chests were purely digital, yielding a stat boost, for example. This does not completely match and needs to be considered. Continuity has this layer of character sheets and player imaginations, for instance, but can extend more into physical space. This does not only refer to having your own figure, but also the figure collecting scuffs, weathering over time, and showing traces of gameplay physically. We can then craft and create this tangible memento that we created and personalized ourselves. When we talk about damage as a design element, it's also crucial to consider sustainability. This is why we had the modular figure design, but on a gameplay level, this endpoint of permadeath and destruction has to be used sparingly. And we, as designers, have this entire gradient between minor scuffs or functional damage to complete destruction available as design elements. We also observed how intransparency can be beneficial when it adds to an element of surprise. This is similar to a game master not disclosing everything to a group of players. However, transparency is needed for aspects like assessment, so that users at some point understand the rules of the game and craft activities become something they have full control over and can anticipate the digital outcomes of it. And lastly, we see this archetype of application to be more than a game experience, but also a way to make first contact with such devices. Specifically, we don't use design or solving mechanical challenges as an entry point, but a hybrid board game that just happens to use fabrication devices to bridge digital and physical spaces. I'd like to wrap up to my talk by providing some limitations, avenues for future work, and some concluding remarks. As for the limitations, this study does have a rather small sample. During the study, the personalization aspect was rather compact, and while developing DungeonMaker, we saw that this is just a probe in a very vast design space beyond. And as a thought exercise, you could pick any board game and think how you could adapt it to a comparable setup and which aspects may emerge. And these limitations directly inform the future work we see in large-scale studies, expansion of crafting and assessment, and these explorations of this design space. So we presented DungeonMaker to conclude, and which is a proof-of-concept hybrid board game that uses fabrication devices to provide elements of creation, sensing, motion, and discretion to a hybrid board game. The individual aspects of it present design elements that can be applied to other board game concepts. DungeonMaker also provides this tight coupling between physical and digital in a hybrid board game. This happens on several layers, like players crafting equipment, with the machinery moving player and non-player figures. This might foster agency, identification, and can also be a way to make first contact with fabrication devices. That's it from my side. Thank you so much for your attention, and thank you to my co-authors. For more details, please take a look at the paper.